For our summary today, I'm just going to give you a quick run through of some of the graphs that we interpreted from class today through our Explore, through some of the things that we've done. So this very first one is temperatures. This is a place in California, La Honda. I know there's probably a Spanish pronunciation, so don't quote me on that one. But I watched a YouTube video on how to pronounce it. Trust me. So we're looking at graphs. So this is a graph of day by day the temperature. So we're looking at what can we do, what can we interpret, how can we explain everything. And the very first question is peaks and valleys, and those are really important features of graphs. Anytime there's a peak or a valley in a graph, that usually is something that's pretty significant. In fact, in a class down the road you'll take called calculus, you're going to study those peaks and valleys quite a bit. That's a huge feature in math. So what do we think those peaks and valleys are? Those are the highest and lowest temperatures in a given day. So as we look at these temperature or these days, there's a peak temperature of about 81 or 82, and then it goes back down to about lower 50s, and then back up to the 80s, back down to the low 40s. So those peaks and valleys are important features that we start to look at. Those are the high low temperatures of the day. When do you think it should be? Usually most people think around noon, 1 o'clock, 2 o'clock, and it does look like it appears that way. It's the beginning and end of the day are the dotted lines. It does appear that it's around noonish, maybe a little bit after noon. And one of the lowest, again, some people think midnight, but usually it gets a little bit colder, and at its coldest, once that sun comes up, that's when it starts to go back up again. And you can look, it looks like, so we can kind of predict sunrise when that sun comes up, which starts to warm up the temperatures again. Are there any, we talked about coldest times of the day, where are those occurring? So again, all of those peaks and valleys, we talked about the maximum temperatures, we've got those minimum temperatures, all of those things, we can explain why those occur where they do. Anything unexpected, those are also things to kind of look for in graphs. And the only thing I really see as far as unexpected goes, it looks like we kind of had a cold day right around August 31st. It looks like it got the coldest that night, around September 4th. Looks like the nights are getting a little bit colder, but really the only odd duck I see is this kind of weird day on August 31st. Maybe the sun didn't come out that day. Who knows? The final one we looked at today is the Logan River. This is a different context, different scenario, and this is a graph. There's two things going on at once, which is another thing that we'll do quite a bit in math, because now we can get even more information from a singular graph. So the very first thing to kind of take note of is the red here. That's the velocity. This is a river, so the velocity of the river. So that's its flow, how fast it's moving. And the blue is the turbidity. And turbidity, if you read up here, it says is the clarity of the water. So high turbidity means murkier water. So low turbidity means it's clear. So we can kind of see some patterns here, and it looks like something weird happens right around here, something different. This would kind of be the result of kind of the normal flow of that river. Okay, things are happening as usual. Everything's in harmony. Everything's nice and smooth, and something happens on the 11th. So let's take a look at the scenario. So for recreation, Jill visited the river in the month of January. She saw clean and beautiful water. Well, when would we expect her to see clean and beautiful water when things are normal? So that I would expect it to be here, somewhere in this window of just things are business as usual for this river. And then it does look like things are going back into harmony sometime after the 15th. So I would guess somewhere in here is when if she visited this river and saw cleanliness, that's probably where it's going to happen. Negative velocities. We talk. There's also things where where it dips below this line. Why is that? Why is that the case? Well, that's just the normal tidal flow of the river. So things rise, things fall, things rise, things fall. So that's what I would expect. That things are normal. Things are going up and down, and like we would expect. And then again, the behavior of the river seems to follow a normal pattern. When do you think this flood starts? Well, that's what we talked about. There's that odd change in normal. So again, the murkiness is high, the velocity is high. Things are not normal for this river. That's what's going to happen. The third example we looked at today was, now we're looking at solar radiation. So how much sun or how much radiation coming from the sun can you expect on any given day? And again, we're going to come back to these ideas of low spots, peaks, valleys, flat spots. We can use all that data to predict what is going on in this city. So looking at the peaks, we talk that's that peak moment of when there's the most solar radiation. It's happening in the middle of the day. That's what we would expect when that sun is right over our heads. So when is the graph, what happens when the graph is flat? Well, as I look, the only flat spots are here down at the bottom. Well, that's at 0. So what's going on there? There's no radiation. There's no change in radiation. That's nighttime. So again, there's no sun coming. That's what we would expect for those things occurring. There's a low spot. Again, what's an odd duck? Remember, we talked about our August 31st is that weird situation. Well, there's very, very little solar radiation that day. And can we use that to predict what's going on? My guess is, based on the temperature we talked about, that was the weird one. The low solar radiation, my guessing it was cloudy, it was cold. That was probably what was going on August 31st. The next context we looked at was accumulation of precipitation. So this is the accumulation of rain, snow, hail, anything that fell from the sky over. Oops, sorry. Over the span of that same time frame. So remember that accumulation means built, like how much is it? So it's not just how much fell that day, it's how much fell during that time that we're measuring precipitation. And that's what's happening. So it does look like, as we look at this graph, it's constant for a very, very long time. So there's this long period where there was no precipitation. It was totally dry those 1, 2, 3, 4, 5, 6, 7 days. So that whole week, not a single drop of rain or snow or anything fell from the sky. And then as we hit, early morning on August 31st, now we start to get some precipitation. Looks like it stopped for a little while. We got some more, and then it settled down for a couple of days. So that accumulation idea. Why didn't it start at 0? All that means is we didn't start from scratch on that day. There was already some accumulation that had fallen, so that's kind of our initial accumulation.